I can see
I
you.
can see Dr. Raul, but I cannot see Dr. Bing.
Yes,
Okay,
okay. Yeah.
that's the difference. And
Okay.
now?
Yes.
Oh,
Dr. Bing, Dr. Raul, our dean is already with us now.
okay.
Uh, Let me introduce you. This is our dean, Dr. Wisnu Barlianto. Dr. Wisnu, this is Dr. Raul and Dr. Bing from Erasmus MC.
Hello. Good morning.
Hello, good morning, Dr. Bing. I
Hi.
am Wisnu. I'm Dean of Faculty of Medicine. Thank you for your uh, presentation. Good
Thank you
morning,
for the
Dr. Raul.
invitation.
Good morning, Pak Dekan. Thank you for inviting us.
Dr. Fitri, maybe we can start.
Okay, thank you, Dr. Ansari. Bismillahirrahmanirrahim. Whom I respect, our honorable guest, Dr. Hoping Tio, PhD from Department of Dermatology, Erasmus University Medical Center, Rotterdam. Our honorable guest, Dr. Juliet Severin, PhD from Department of Medical Microbiology and Infectious Diseases, Erasmus University Medical Center, Rotterdam. Dr. Raultan Hadinagoro, PhD, Senior Advisor for International Affairs, Erasmus University Medical Center, Rotterdam. The Dean of Faculty of Medicine, Universitas Brawijaya Malang, Dr. Wisnu Barlianto, Pediatrician Consultant, MSI Med, and all the Vice Deans. Staffs of International Collaboration Unit, Faculty of Medicine, Universitas Brawijaya Malang, Head of Medical Schools, Head of Residency Programs, Head of Departments, our beloved teachers and medical staff from Faculty of Medicine, Universitas Brawijaya, and Dr. Saiful Anwar, General Hospital Malang, and all our honorable guests and audience. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I would like to extend a very warm welcome to you and appreciate your taking time off your busy schedules to join us today. My name is Nur Rahma Fitri. It's an honor for me to be your master of ceremony in this very special occasion, International Collaboration Webinar, themed Microbiome and Microbiota in Human Health, between Faculty of Medicine, Universitas Brawijaya Malang, Indonesia, and Erasmus University Medical Center, Rotterdam, the Netherlands. First of all, let us say gratitude to the Almighty God who gives us guidance, happiness, health, and mercy, so we can attend and participate in this special event without any obstacles. Once again, I would like to welcome Dr. Hoping Tio, PhD, Dr. Julian Severin, PhD, and Dr. Raultan Harinegoro, PhD, as our main guest today, and of the audience. In this webinar, we will have several agenda as follows. The first is opening. The second is opening speech from Dr. Wisnu Barlianto, Pediatrician Consultant MSI Med, as the Dean of Faculty of Medicine, Universitas Brawijaya Malang. And we continue with first session of the main lecture by Dr. Hock Bing Tio, PhD, entitled Skin Microbiota and Immune Skin Diseases from Pathogenesis to Therapy, followed by speech from Dr. Raultan Hadinegoro, PhD, Senior Advisor for International Affairs, Erasmus University Medical Center, Rotterdam, and we then followed by discussion for section 1. And we have a moment of break for photo session, and then we continue with the second session of the main lecture by Dr. Juliet Severin, PhD, entitled The Emergence of Antibiotic Resistance in Human Intestine Flora Caused by Overuse of Antibiotics, and followed by discussion for session 2. And the last agenda for this day is closing. Now, let us open the ceremony by saying prayer according to our religion and beliefs. The prayer may start now. Thank you. And before we start our agenda for today, we would like to show a profile video from our beloved campus, Faculty of Medicine, Universitas Brawijaya, Malang. The video may start now.
Faculty of Medicine, Universitas Brawijaya. Our vision is to become the leading standardized internationally and entrepreneurial medical institution to improve the quality of life of the society. Our mission is to develop the current and qualified medical education, research, and community service to build the future nation based on universal values. Faculty of Medicine Universitas Brawijaya originated from a private medical school, namely Malang School of Medicine or STKM, established on 14 September 1963. Years later, a letter from the Ministry of Education and Culture converting STKM into a public institution. STKM officially joined Universitas Brawijaya on January 14, 1974, and it was renamed as Faculty of Medicine Universitas Brawijaya. Currently, Faculty of Medicine Universitas Brawijaya offers 33 diverse study programs, which are 5 undergraduate programs, 5 health profession programs, 4 master programs, 1 doctoral programs, and 18 medical residency programs. As one of respectable university in Indonesia, Universitas Brawijaya adds 4,700 students to its student bodies every year who come from all over Indonesia with competitive selection. Faculty of Medicine and Universitas Brawijaya provide several facilities to its students. For clinical teaching of our students, we also partnered with several hospitals in the East Java area. In accordance to our vision and missions, we also involve our students in several special activities such as entrepreneurship, medical emergency and disaster management, also sports and arts. We built our research tree based on the root of biomedical translational research. Several research groups already established in the Faculty of Medicine Universitas Brawijaya, and the continuous improvement and research is on the way. Faculty of Medicine Universitas Brawijaya. Join UB, be the best.
Masih di mute Mbak Fitri.
I'm sorry for the troubleshoot. Okay, the next agenda is opening speech and brief presentation from the Dean of Faculty of Medicine, Universitas Brawijaya Malang, Dr. Wisnu Bardianto, Pediatrician Consultant and FMUB-EMC. For Dr. Wisnu Bardianto, the time is yours.
Dr. Wisnu.
Suara saya sudah kedengaran?
Sudah dok. Tadi
Apa bisa didengar suara saya?
bisa dok.
Bisa, Dok.
Oh, ya. Ini kok
Tapi
sinyalnya
terputus-putus,
jelek ya,
Dok.
putus-putus kelihatannya.
Iya.
Ya.
Sebentar.
Jelas, Dok.
Sudah jelas ini, Mas, putus-putus?
Sudah, dokter.
Apa masih putus-putus?
Sudah jelas dokter.
Oh, sudah jelas ya. Baik, saya. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable, our guest lecturer from Erasmus University Medical Center Rotterdam, Dr. Aul Tan Hadinagoro, Dr. Hok Bin Tio, and Dr. Juliet Severin. Thank you for your time to present your lecture today. And one of our vision and mission in the Faculty of Medicine, Brawijaya University, is to become among the respected international universities. Therefore, and community service is always and in the future might help rise our thinking. Hence, this guest lecture was arranged with our collaboration with Erasmus University Medical Center, Rotterdam, the Netherlands. Research has been conducted in recent years, often discussing the microbiome and microbiota roles and its role in health and diverse diseases. That a cohort study as part of the Human Microbiome Project found that there might be more than 8 million unique genes associated with the virus microbiome in the human body. The total human microbiome can make a genetic contribution to each person several hundred times larger than the entire genome. In addition, the role of the microbiome and microbiota in the outermost layer of the body, namely the skin, is also no less important, serving as the outer interface of the human body with the environment. The skin acts as a physical barrier to prevent the infection of foreign pathogens while providing a home for the commensal microbiota. We will discuss the role of the microbiome and microbiota at the guest lecture as Dr. Bing Tio and Dr. Juliet Severin from Erasmus Medical Center, Rotterdam, Netherlands, will give the talk about this topic today. I hope that this event will be a good kickstart for our collaboration and will benefit both the Faculty of Medicine and the Erasmus University Medical Center Rotterdam in the future. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Wisnu Bardianto, for the speech. And ladies and gentlemen, now we come to the main event for this webinar, which are lectures from our honorable guests from Erasmus University Medical Center. Before we start, allow me to introduce our moderator, Dr. Herwinda Brahmanti, Master of Science, dermatovenerologist consultant. She was born in Malang on October 7, 1980. She is a lecturer in Faculty of Medicine, Universitas Brawijaya, and also our head of dermatology and venerology residency program. She is also an active researcher and writer with prominent interest towards immunodermatology. In Collegium Dermatology and Venerology, she is active as a member of Curriculum Education and Adaptation Commission. She is also a member of Immunodermatology Research Group in Indonesian Society of Dermatology and Venerology, and a member of European Academy of Allergy and Clinical Immunology. For Dr. Herwinda Brahmanti, the time is yours.
Okay, thank you, Dr. Nurrahma Fitri. Good afternoon, ladies and gentlemen. It is very honorable for me to be a moderator in this very special event. This event is hosted by International Collaboration Unit, Faculty of Medicine, Universitas Brawijaya. And also, I would like to say thank you very much for the Faculty of Medicine, Universitas Brawijaya, especially in an International Collaboration Unit, Faculty of Medicine, Universitas Brawijaya, and the organizing committee for giving me a chance to be moderating in this special event. This afternoon, we have our guest speakers from Erasmus University Medical Center and also senior advisors from International Affairs Department of Erasmus University Medical Center in Rotterdam. And we very hope one day our guests will be able to attend directly in Indonesia. And right now we have to meet virtually because of the pandemic. Because in the curriculum vitae, I read that Dr. Hogbing Tio and also Dr. Rautan Hadinogoro must have a very special memories about Indonesia. And also hope Dr. Juliet Severin can enjoy the beauty of our country. Okay, well, let's we start to our first guest speaker. Allow me to read the curriculum vitae of Dr. Hogbing Tio, PhD. Hogbing Tio, MD, PhD, was born on 2nd April 1960 in Surabaya, Indonesia. He is a full-time dermatologist, consultant, and vice chair in the Department of Dermatology, Erasmus University Medical Center in Rotterdam. His PhD thesis in 1999 was entitled Clinical and Basic Aspect of Fumarates in Psoriasis. And also, Dr. Tio has been a principal supervisor or investigator of clinical studies and translational research on psoriasis and also in atopic dermatitis. Dr. Tio has authored and co-authored several papers in peer-reviewed journals. And at this moment, he has collaboration research project with Indonesia and also with Thailand. And in 2019, Dr. Tio was awarded with the 2019 Baluang SN Chair Professorship Grant for setting up translational psoriasis research at the Department of Dermatology at the Thammasat University in Bangkok, Thailand. Okay. Dr. Hogbing Tio in this afternoon will be presenting an interesting topic about skin microbiota and immune skin disease from pathogenesis to therapy. Please, Dr. Hogbing Tio, you have 15 minutes. Now time is yours.
Thank you. Thank you very much, Dr. Herwinda. How are you?
Thank you.
Is this 15 minutes or 45 minutes?
45 minutes.
Okay, I'm sorry, 45 minutes.
Okay. Otherwise, I have to shorten my presentation.
No.
You don't need to stop.
Okay.
Please.
Okay. Thank you very much, everyone. Good morning and good afternoon, of course. Selamat siang over there in Malang. Thank you very much for having me here on this webinar. I'm trying to share my screen. How can I share?
Can you share your screen, Doc?
Yes, I share my screen now.
Okay.
Can you see it?
No, not yet. No.
Not yet, Doc.
After you click the green one, share screen, and then
Now?
please click the desktop or your PowerPoint and then click share.
Click share.
Yes, the blue button share.
Yes. But why is it then that it didn't share at all?
Really?
I need to start my video again.
Please stop sharing and try once more, Prof.
Okay. Sorry, everyone.
It's okay. Be patient, waiting for your lecture
So,
because it will be
so
great.
this is my so I got my PowerPoint now.
So put the after the click share screen, and then click the desktop one is okay, and then share.
Yes.
And then
But I can't share here.
the share screen,
The blue one on the
the blue one
corner.
on the yeah lower right lower corner.
Is that here share screen? That's a green one. And I
Yeah,
see your I
yeah,
see your screen.
yeah. It's okay. Desktop one, and then click share, and then you can open your
I don't
PowerPoint.
see okay. Is this the right one?
Yes, yeah,
Yeah.
Okay.
Okay.
clearly.
Yeah,
Thank
I
you.
see the picture of me,
Thank
Prof.
you. Yeah. Okay. So
Okay.
this is hi everyone. So this is once again, thank you very much, and also thank you the dean for welcoming and opening the whole session. This is beginning of March. Sorry,
Sorry,
everyone.
Professor,
Yeah,
can you make the screen is smaller because we just can see the part of your screen?
smaller.
Yeah, this one and screen show.
Let's
Yeah,
show.
Slideshow.
oh slideshow. Sorry, slideshow. Yeah, okay.
Okay.
I show.
That's
Is this
perfect.
okay?
Good.
Yeah, this is perfect. Thank you.
Okay. Going back again. Okay. So this is a picture from last time I was there on the invitation of Dr. Anshori and the whole department, dermatology, and Dr. Herinda. And you see here that this is the pre-corona time, just at the beginning. And I've also to disclose myself, as you can see, Dr. Brawijaya has given me already a lunch last time. So that's also a disclosure, of course. And thank you very much once again. And talking about food, makanan, then we are we are talking about microbiome. The most important microbiome is, of course, in our gastrointestinal tract. And in the gastrointestinal tract, there is 95% of your microbiota is located there. There are about 90% of human diseases can probably be linked to this microbiome, especially in the gastrointestinal tract. As you can see, in the gut microbiota, there is much more viruses than bacteria in a ratio of 5:1. And the genes, and that's also very important one, the microbiome has 150 times more genes, outnumber our score, our genome, which is of course about 22,000 of genes, our human genome. And talking about microbiota, there's another Dutch guy from Delft, Leiden. He is the inventor of the microscope. That's Antonie van Leeuwenhoek. And I see here that Leeuwenhoek is wrongly typed, but it's Leeuwenhoek. In 1680s, he already noticed that there are microbes in the samples taken from the mouth and from the feces. And there are differences between the microbes in the mouth and in the feces. If you're dealing with microbiome, then there is the connection of microbiome with the immune system. And the immune system is then causing the disease. So the relationship between microbiome and human health is transferred by this immune system. As you can see here, in a very, with small text, you can't read it all, just showing you that almost all the organs of the human body is somewhat related to your gut microbiota. And you can see also here that to your left, the gut skin axis, that there are many things happening in your gut which can have via your immune system an influence on the skin. Just telling you now that the most important part of the gut is probably here at the ileum, at the entrance of the cecum. Why? Because here is the biggest lymph node of the human body, the Peyer's patch, as you know, and there is the interaction of the gut microbiota with the immune system, especially the Th17 cells and the Tregs, the regulatory T cells. But of course, I'm a dermatologist, Dr. Erwinda is a dermatologist. We are going first to the skin. What's happening in the skin? I told you already, they listen to the gut, what's happening in the gut. So what you eat, what the impact has on the gut microbiome, and after that on your immune system, and that immune system has an impact also on the skin. But the skin itself has on the other side many bacteria, viruses, and fungi sitting there. So in normal healthy situation, like also in the gut, your microbiome is protecting you, doing nothing, not causing any infection. It's just sitting there, helping the immune system to protect your body of diseases. As you well know, that the skin has its own renewal of 28 days. Every month you have a new skin. Why? Because we have a lot of stem cells, not only here at the basal layer, but also in the hair follicles, and here also in the subcutaneous fat. We have many stem cells. So we are capable to renew the skin every 28 days. So you can see here the microbiota of the skin of bacteria, viruses, and fungi and yeast. How can you do some disseminations? You can do it simply by amplicon, by the 16S bacteria, and for the ITS, you can do this for the fungi, while much more expensive, but you can do this, and it's more detailed. This is the whole genome metagenomics, and this NGS methods, you can do the whole genome of all the bacteria, viruses, and fungi. So normally speaking, at this moment, most of the studies are doing this amplicon method. And that's good enough, but in the future, you should go to this more expensive whole genome thing. So once again, in the skin, the function of the skin microbiota is protecting you from diseases. So if you have a normal skin microbiota, then you call it symbiosis. It's sitting there, living in a very peaceful environment with the skin. There's nothing happening between the skin microbiota and the immune system. Something happening is something is changing in the skin microbiota, then the immune system is thinking, oh, what's happening there? And then they will get activated, the immune system, and then you will get the skin disease. Like in atopic dermatitis, you know, the Staphylococcus aureus is one of the main contenders in causing exacerbations of the skin diseases, of the skin disease atopic dermatitis. Here's also another Staphylococcus name, the Staphylococcus epidermidis, and this is probably a good one. Staphylococcus epidermidis is now focus of research of many cosmetic industries and also pharmaceutical companies. Why? Because that's a very good for your skin health bacteria. Staphylococcus epidermidis, remember that one. This is a picture, a graph from, as you can see here, Sager and Belke. Those are the two main female scientists and knowing everything about the skin microbiome. If we are dealing with the skin microbiome, remember that we have 2 square meters of skin organ, and we have a very oily sebaceous glands rich areas. That's almost the face and your hair. And the moisty areas, that's on the folds, on the body folds, like here in the elbows or on your knees. And you have the foot as special area. A lot of fungi are sitting there as the most important inhabitant of your skin microbiota. And the rest of the body, the biggest part, is the dry area. And in this dry area, that's especially, I told you already, Staphylococcus epidermidis, that's the most important bacterium for a good skin health. So in skin diseases, you have sometimes a loss of your Staphylococcus epidermidis. So one of the therapies possibility in the future is giving in your ointment, in your cream, Staphylococcus epidermidis and apply it into the skin. In this oily areas, it is the Malassezia furfur, which is, as you can see here in the middle part of the fungi, the biggest and the most important inhabitant of the skin microbiota. For the people who love to know everything, as you can see here, these are all the known and the most important inhabitants of your skin microbiota. As you can see here, bacteria, many bacteria. So everyone here participating in this webinar has this skin microbiota, but there are differences, there are individual differences. But as you can also see here, that like the molluscum contagiosum virus, that's a kind of a watery warts on the skin. I can show you. These are molluscum contagiosum lesions in the elbow of an atopic dermatitis patient. Why? Because there is something happening in the skin microbiota that the molluscum contagiosum virus can be growing a lot, an outgrowth of this virus, and then you can see this molluscum contagiosum. So molluscum contagiosum is a member of the skin microbiota, especially here, as you can see, in the moist areas. Sorry. So that's the skin microbiota. Just remember that, of course, if we are dealing with skin diseases like psoriasis, atopic dermatitis, acne, skin microbiota is playing an important role, but there is this 95% gut microbiota is always telling you that they are the main health influencers in the human body. So there is first the gut and then thereafter the skin microbiota impacting the health of your patient. Yes? So, and how is this happening then in the gut? Of course, if you are eating some food, the food will be metabolized by the bacteria, viruses, and the fungi in your gut microbiota. And they are then producing metabolites like the short chain fatty acids. And of this SCFA, short chain fatty acids, now is butyrate one of the most popular one. And butyrate can then have an impact on your immune system cells located in the Peyer's patch, as you know, nearby the ileum and the entrance of the cecum, of the colon. And one other thing that we need to say is that where you live, the soil and the plants has also an impact on your gut
Halo,
microbiome.
Mbak.
Yeah? Hello? Hello?
Please continue, Doc.
Oh, okay. So that if we will do investigation of your gut microbiota, I probably can tell where you live in Malang. And so if the soil is very, very empty and there are no plants like in the desert, that's a different gut microbiota than if you're living middle in the woods of Malang, outside Malang, or somewhere on Java. And this is a very complex picture, just telling you this was happening in the ileum area in the Peyer's patch. There is this interaction between your gut microbiota producing a lot of metabolites, as you know already now, the short chain fatty acids, and impacting many, many different, especially T cells. The Th17 and Tregs are the most important one, but also Th2 important in atopic diseases and in allergies, but also Th1, it has an impact. So the gut microbiota here has an impact via the Peyer's patch on your immune system. Another important thing is if something happening in your gut, then the barrier will be somehow disrupted. So you have a poor barrier function. In that way, many, many things can enter here and can be focused and can be, your immune system will then be extra stimulated by this entering antigens from your gut lumen into the body. So back to this picture. This is just telling you once again, it is the microbiota. That's the bacteria, viruses, and fungi in the gut, but also on the skin, has an impact on your immune system, especially Th17 and the regulatory T cells. Those are the inhibitory T cells. So if you have a lot of Treg activity, then the disease will be dampened. If you have an immune system disease, sorry. And so this interaction of your microbiota with your immune system, this is the most important interaction in causing diseases. And not only atopic dermatitis, psoriasis, as you can see here, but many, many other things. Just for your interest, of course, diabetes and obesity is a big problem, not only in Europe, but in the whole world, especially the diabetes. And for diabetes type 1, so the insulin-dependent immune-mediated diabetes, there is now very, very promising results. Just yesterday, brought to the science journals and also to the news on TV and radio stations is made by a group from Amsterdam, and they are saying that the fecal transplantation, so you transplant the good microbes and to a diabetes patient, and the diabetes will be going much, much better with this good microbes of people without diabetes. That's the fecal transplant. If we are just one other thing, small thing, that your gut microbiome, if you're a healthy person without any kind of diseases, then your gut microbiome is under influence of many, many things that you can see here, not only on your diet, but also if you're taking painkillers, paracetamol or aspirin, or you have a lot of stress, and exercise is a good one for your gut microbiome. The whether you get breastfeeding or not, the birthing process, whether cesarean method or just a normal natural birthing process. And this is an important one. There is a lot of change going on if you're getting older. So the gut microbiome of an older patient is completely different than from a child or an adult person. A strange picture this, as you can see here, Indonesia is deleted. But I thought this is very funny, but I'm very sorry that it's not visible here, Indonesia. And this is also what the climate change people, the global sustainability, which is very, very trendy at this moment. If you are striving to a good health, remember that good soils and sustainable agriculture using all this bio control microbes and biofertilizers is much better for your health than a very fragile plant microbiome. So once again, if you want to have a good health, it's not only what you eat, but your surroundings very important, and especially in your living areas. This is, I told you already about diabetes and the fecal transplant, and you can change your microbiome by using antibiotics or phages. Those are viruses infecting the bacteria, bacteriocins, antibodies. Also by using, of course, good food, healthy food. In that way, you can promote some bacteria, the good ones, and with the antibiotics, you can inhibit, you can kill the bad bacteria. Told you about the diabetes. You can also use probiotics. Those are the good bacteria. You bring it directly. Fecal transplantation, of course, not the raw feces, but it is already washed away. You just only isolate good bacteria and bring it as close as possible to the Peyer's patch. That's at the beginning of the colon, at the end of your ileum tract. That's what you have to bring your fecal transplant material. Back to the dermatology. What about psoriasis? As you know, this is the most famous, important skin disease, immune-mediated skin disease. Psoriasis is probably the model for immune diseases in general. If you have a pharmaceutical company and you have something to block your immune system, like anti-interleukin 17 or 23, or you always test first at in these diseases, in a skin disease psoriasis. If it's working there, then you can test it out for rheumatoid arthritis or Crohn's disease or other immune-mediated diseases. This is what's happening in your microbiome if you have psoriasis. This is the normal skin. As you can see here, there is Staphylococcus, probably Staphylococcus epidermidis, of course, Propionibacterium acnes, the most important bacteria in acne, but is sitting here as a normal, peaceful inhabitant of your skin microbiota. So this is a normal, healthy one. LC stands for Langerhans cells, antigen-presenting cells. Here, these cells. If you have the immune disease psoriasis, then you can see that everything is getting stimulated. Your immune system, of course, especially the Th17 cells, but also Th1, causing a hyperproliferation of the keratinocytes of your epidermis. And you can see here also that there are changes in your skin microbiota. One of the therapies of psoriasis is light therapy. You can go out and lying down under the sun light. That's the cheapest one probably, but you can also go to light therapy in hospitals. Giving light therapy is you're using the UVB, and UVB is causing immune suppression, and that's why it is very efficient in treating psoriasis patients with UVB. UVA, that's a lot more in sun, and it's causing a lot of skin damage, and the wrinkling and the aging in humans, mostly of the causes. The most important one in the sun is the UVA, causing all these small damages into the skin. So psoriasis is now known that there is something happening in your microbiome causing immune system activation and causing also the skin disease. In acne, that's another skin disease which you can see very, very often. Almost everyone gets it somewhere in your life. Then you can see here that the Cutibacterium acnes and the Staphylococcus epidermidis are the two most important microbiota inhabitants playing a role in the pathogenesis of acne. That's why you give sometimes antibiotics as a therapy to eliminate this Cutibacterium acnes. And the Staphylococcus epidermidis in acne, that is something of a topic of discussion. If you are younger than 20 years, then the Staphylococcus epidermidis is high in numbers. Then you need to eliminate the epidermidis. But if you're older than 20 years, the epidermidis is lower. Then you need more of your Staphylococcus epidermidis. Instead of killing them by antibiotics, you need to apply the Staphylococcus epidermidis. And this is how dermatologists also should take care. Is doxycycline is not working, please remember that maybe you have to do something else to promote the epidermidis, and in that way causing an effect of your therapy in acne. So this is in a table, just the details happening, what's happening in the skin microbiota in acne. As you can see here, also other bacteria can play a role. Also the Malassezia species. And in your gut microbiota in acne patients, you see a higher number of the Bacteroides, especially the Bacteroides fragilis. And there's another picture for diseases, especially for like schizophrenia and Parkinson. Something is happening in your gut microbiota. I only want to tell you here for diabetes type 1 that the Bacteroides fragilis is also very high, comparable as this situation in acne. And how can you then treat this bacteroides? Of course, by using antibiotics. And as you can see here, with this fecal microbiome transplantations, we can do this now. And of course, not giving Bacteroides fragilis, but more other bacteria. In that way, you can just inhibit the growth of the Bacteroides fragilis. One research question you can ask: how is the situation in a younger patient with diabetes? Is there more acne or less acne? We don't know yet, but maybe we have to do more research in that area. How is the situation of acne in the type 1 diabetes patient? Now we are going more in atopic dermatitis, more in the Th2 diseases, which an important role of the mast cells, and which there is a damaged skin barrier and also dysbiosis. Dysbiosis is a dysfunctional skin microbiota. So it's not peaceful anymore. The skin microbiota can then act as immune stimulators. Okay. This is a picture, also a very complex one with many things in it, but just only telling you that try to remember that in Indonesia, an Indonesian patient with atopic dermatitis could be different than the European American atopic dermatitis. And you see here that here in Europe and in the United States, Th2 is probably the most important T helper cell in causing the disease, and also the Th22. But here in Asian patients, it almost looks like psoriasis. Th17 is very important together with Th22. Here's the comparison, the situation in psoriasis. You see here that is sometimes difficult in Asian patients to see whether this is atopic dermatitis or whether this is more psoriasis. This is, of course, atopic dermatitis. And this is a graph. And this article I can recommend you because not only dealing with the skin microbiome, but also the gut and the lung for the lung disease people. There is important here in the skin is the Staphylococcus aureus. If you have a dysbiosis, loss of microbial diversity, and an overgrowth of Staphylococcus aureus, then you will get an exacerbation of your atopic dermatitis. You can see here this more kind of the Th2 activation, and it stimulates by interleukin 4 and 13 the B cells, getting plasma cells, producing IgE, and activating mast cells and basophils. And also in the gut of atopic patients, many things are happening here. Also, butyrate, as told you, this is the most important short chain fatty acids. Another cell in the immune system is the innate lymphoid cell type 3, is doing things, more repairing of the damage caused by the dysbiosis. And also in the lungs, and especially now with the COVID, remember that an atopic patient has probably more chance of fibrosis if you get COVID. And one important thing right now is, and I will bring this next Saturday on the European Dermatology Congress, about the role of pollution and the skin microbiota, and how can you protect your skin from pollution, is that the human skin is on the outside of the body, And that is the major barrier for pollutants. Once again, if you have lockdown like now in COVID pandemic time, then you have less pollution, then you have probably a healthier skin than without the COVID. This is just showing you that this PAH, polycyclic aromatic hydrocarbons, has an impact on your skin microbiota, and in that way has an impact on your immune system, and in that way causing changes in your skin health. And not only pathogens or your skin microbiota, there are many other factors impacting on your skin health and causing changes. And one thing, if you want to remember what's happening in pollution, you have an activation of this aryl hydrocarbon receptor. This is the most important receptor as an intermediate between pollution and your human body good health. And there is a lot of reactive oxygen species production, and in that way causing a lot of damage in your especially dermis area and the skin, but it also causes a lot of inflammation. That's why in polluted areas you have a lot of eczema in the face caused by these pro-inflammatory cytokines, especially the interleukin 6 and the 1A, 1 alpha, and interleukin 8. And once again, in pollution, now all the cosmetic companies are focusing their research on trying to bring more Staphylococcus epidermidis on the skin, into the skin microbiota, and that way protecting you from the damaging effects of pollution. With this reactive oxygen species, activation of the aryl hydrocarbon receptor, you can cause premature aging. You see more wrinkles earlier in your life if you're living in a polluted area. This is also in the Lancet of the 2018 report, what does climate change to the world? As you can see here, a lot of flooding, tsunamis, and drought, heat waves, but also bushfires like in California in the United States. And that way can cause many different diseases of different organs. That's not only on the skin, but the most important organ is the lungs. Due to pollution, you can get lung diseases. And also via the lungs, it can go to the brain, blood-brain barrier can pass through these cytokines, and then it can cause, especially the microglia, can cause neuroinflammation and can cause neuronal cell death. So neurodegeneration, that's a big problem in pollution areas. So not only seeing what's happening on the skin, but remember that via the lungs, you can also cause a systemic inflammation and also causing neurodegeneration. And try to remember also that air pollution can cause different things on many immune cells, and in that way can cause diseases. That's why we are also looking at rural and urban areas. Is there something happening and changes notice in human health in rural areas and in big cities? And told you earlier, if you have this COVID-19 pandemics, it has an impact on many things, and also on this climate change things. In general, probably COVID-19 is doing good things on not on the economic activity, but on this climate change thing. So it's probably healthier for the humans, but COVID-19 itself is, of course, not so healthy for the humans. So, trying to end up my presentations, is there something which we can eat? Yes, there is a lot of healthy food, but try to remember also that if you are talking about healthy food, then it's always good for your immune system. But if your immune system is already overactivated because you have a disease of your immune system, like psoriasis in the skin, then don't eat too many healthy food in causing your immune system to be uh, get better, and in that way the psoriasis will get also will worsen because you're eating too healthy for your immune system. Just in general, you're trying to also to summarize. So once again, microbiota, the gut microbiota, that's 95% of all the microbiota. Not only the gut, but also the skin has its own microbiota, but also the oral cavity, your nose or your genitals, like the vulvovagina area. That's very important in gynecological diseases. If you have a healthy microbiota, and remember also try to protect yourself from pollution, and because it has an impact on your immune system, then you have this integrated immune response. Then you have a balance in pro and anti-inflammation. This balance is very important for your health, and the microbiota has an impact on this balance. If you have a disbalance, then you can have an overactive immune system. You have autoimmune diseases like psoriasis or Crohn's disease or multiple sclerosis. But if you have a less active immune system, then you get more cancer and infections. And this type of immune reactions in leprosy is a very focused research in Indonesia. And you can see here that I'm doing this together with the UI in Jakarta with Salma Oktaria, and now also with Surabaya with Professor Chita and Effie, Dr. Novianti Rizki. We are looking at leprosy, whether the microbiota is different in leprosy patients than in non-leprosy patients. And we like to compare this with the overactive immune system situation that's in psoriasis. In that way, we can see what the role of microbiota is in causing autoimmune disease like psoriasis or in causing infectious disease like leprosy. I hope I have told you a kind of introduction in the role of microbiota, and that there is an important role of microbiota, not only of the skin itself in skin diseases, but also of the gut microbiota. And thank you very much for your kind attention. And I'd like to, if you want to go after this COVID pandemics, to go to Europe and somewhere in June, please be welcome. There is an inflammation congress, international one in Rotterdam, 23rd to 25th of June. You are more than welcome to join us. Terima kasih banyak.
Terima kasih.
Okay, thank you, Dr. Tio, for the very interesting explanation about skin microbiota. And we will have our discussion for the next session. But before that, please welcome an opening speech from Senior Advisor for International Affairs from Erasmus University Medical Center, Dr. Rautan Hadinagoro. First, allow me to read the curriculum vitae of Dr. Rautan Hadinagoro. Dr. Rautan, his name is Chu Liang Rautan Hadinagoro, PhD, KRT. He is graduated from the Faculty of Natural Science and Medicine in Leiden University and obtained his master's degree from the Faculty of Natural Sciences in 1997. His Master of Science thesis on immunology and was done at the Leiden University Medical Center. His PhD research was on 1997 till 202 was in DNA damage caused by chemo and radiotherapy under supervision of Professor Higmaker and Karnar at Erasmus Medical Center. And in 2009, he returned to Erasmus Medical Center as Advisor International Affairs and as Research Policy Manager. Since 2016, he also advises for NIH R01 and R021, and since 2018, advises on Erasmus Plus outside the EU and nation to his main interest, which is global research network and trend in international research collaboration. And Dr. Tan also have a lot of honor and awards, and also have a lot of publication as a first or co-author, and also as a corresponding author. Okay, please, Dr. Tan, now it's time is yours.
Thank you very much. That was really too much honor to do this. I have been asked because, yeah, Universitas Brawijaya, or actually your faculty and Erasmus Medical Center, have been working on a special partnership. So, since most people, staff at the Facultas of Kedokteran, do not know Erasmus-MC very well, except for that small circle of people who are working towards it, I have been asked to give you a short introduction on Erasmus-MC. Actually, I have never been at Malang, but I do feel already very familiar with it because Dr. Devi Santosaningsih is one of your staff members. And actually, what most of you probably don't know is that she still holds the Erasmus-MC record as PhD student with most lecturing hours.
Yes,
Next to Dr. Devi, there's also something else which is familiar, which is actually between our faculty. I just heard that your Facultas Kedokteran was founded in 1963. Our Erasmus-MC, the Faculty of Medicine, was founded in 1966. Also, your university was not as many other universities established by the government and then they founded the faculties. No, it was the other way around. So your faculty was founded first and then established the university, the Universitas Brawijaya, in 1974. The Faculty of Medicine in Rotterdam did actually the same thing. We were established in 1966, but we established Erasmus University of Rotterdam in 1973. So just 1 year before you, which makes us very much, partners having also the same ancestry or history. So Erasmus-MC nowadays is actually a merger of the Erasmus University School of Medicine and 3 university hospitals with 1 executive board and all at 1 campus, which makes us having 4 core activities rather than a School of Medicine alone. Because we are merged with the hospitals, we have patient care, and then also our typical Faculty of Medicine duties like education and training, research and innovation, and valorization. To give you an overview, we have about 16,000 employees. We have a little less than 1 million outpatient visits. It's probably less than what you have. But as you may remember, the Netherlands is a very small country. So for us, this makes us already the biggest university hospital or university medical center in the Netherlands. We have about 4,500 students, 1,000 PhD students. And our hospital is unique as we don't have 2 patients or 4 or 6 or 10 or 12 in 1 room. It's a 1,000 single patient bedroom hospital. So translated to the Indonesian situation, it's a 1,000 bed VIP hospital. What we are actually seen from the academic point are most proud of are our supervision rates. So we have 750 university medical specialists but we have 1,000 residents whom we supervise. So the supervision rate is nearly 1-to-1. The same holds for our scientific staff. We have about 1,500 scientific staff, plus an additional 600 postdocs, and those are responsible for supervising and training of about 1,250 PhD students. We have about 250 PhD graduations a year. Also, in the Netherlands, we are in the only medical school offering all medical specialties. Well, I noticed, and of course from the previous session by Professor Bing, but yeah, I also know that the partnership between Erasmus-MC and Brawijaya that we are trying to develop is focused on research. So to give you a general impression, last week the US News Global University Ranking appeared. So there are many different subject rankings. I don't go for the general ranking, but for us as medical school. So there are lots of subject rankings in within the domain of medicine. But I think for us, the things we are currently focusing on are public health, infectious diseases, and immunology. And for that, we do have a good ranking. So infectious diseases is more on the clinical aspect, but we also do a lot of preclinical work. And for that, the Nature Index of Biomedical Sciences is more important, which shows that we are also world number 30 for the preclinical side, so the biomedical sciences. However, this is of course just rankings, and you probably know that rankings are based for 25 to 50% on reputation. We are, on the other hand, only interested in research and research collaborations. So actually, this is a generic ranking. We can look in different ways, but what I'm more interested in for our special partnership is how we do our international collaborations, and in particular on research. So in fact, I just show you two collaborations in practice. One is a big collaboration we have in South America on liver cancer. So there were two professors, Boonstra and Debus, in hepatology. And they connected to a South American network because Dr. Debus, or Professor Debus, he actually is from origin an Argentine person, and he has a lot of alumni and also former medical school friends from South America. But he went to Rotterdam to become a senior staff member at our side. So those persons, Boonstra and Debus, they became a coordinator of a European research grant, which was together with South American scientists from Argentina, from Brazil, Chile, Colombia, and Ecuador. And also they added it to their existing European partners. So that is what they did. They reached out to their old friends and alumni and shared with them their European partners. So as primary, so what they did next to it, they had a Horizon 2020 grant, and then they also looked for available scholarships, both for research masters and PhDs from Brazil, Chile, Colombia, and Ecuador. And in addition to that, they also applied with the partners from Brazil and Chile for research grants. And we also applied, and of course we got an Erasmus Plus grant, which is a European education grant for exchange, which they did with Argentina. And it started maybe in liver cancer, but the spin-off effect was they started small, and then they also involved all of those partners into their COVID collaborations. Of course, with Indonesia, we have our infectious diseases. And we already had contribution to some Indonesian education and training programs, both from the Department of Public Health for infectious diseases. So they helped the curriculum development with their own alumni at one of the universities. Actually, there was UGM. And the medical microbiology, from which Dr. Juliette Severin originates, they developed also a residency program at 4 universities. So they used both LPDP and Ristek Dicty scholarships for that. And they also had some research grants from the NWO, which is the Dutch Research Council, the KMW SPIN program. And we also applied for Erasmus Plus with our Indonesian partners. And we have those with Indonesia, but we also have them with Thailand, with South Africa, and well, Argentina, and many others. And they are just based on our infectious disease and dermatology consortia. So the idea of the collaboration is when we work out our partnership with you, that you're also connected to our dermatology partners in Thailand or our infectious disease partners in Colombia. And yeah, Dr. Severin also obtained the Fleming Funds fellowships for Indonesia, and that is also a possibility we're working on. So this is basically how we drive our international collaborations. As you see, both in the previous and on this slide, I name our alumni, and I know they're very important because, yeah, in Europe we have a very different culture as compared to Indonesia, both a social-cultural difference, but also a funding and research difference. So it's very important to understand the needs of us and of Indonesia, and to understand our Dutch very direct way of conversation and the more subtle and more refined way of conversation in Indonesia. And alumni who have been at both sides understand both parties best and can translate it. For example, a very direct message from the Netherlands, they can translate it in a more refined way to the Indonesian partners. So that's about two practical examples. But if we talk about alumni, then we are also talking about collaborations by education. And I start with a generic education before I go into the research education, which is the more interesting part maybe for your side, for Universitas Brawijaya. But maybe it's also good to know a little bit more about our philosophy by telling a bit about our medical education. So the medical education in the Netherlands takes 6 years. It's entirely in Dutch because it's focused on the Dutch patient. And I think in Indonesia, it's similar. Most medical education in Indonesia is in Indonesian, as you have to serve the Indonesian patients. So in the Netherlands, we have the most research-focused medical education, and 1/3 of our final year students have also published a scientific paper. Over 75% has international experience before graduation. So we have 410 medical students who enroll every year, and we send out over 300 medical students every year. Of course, this was in the pre-COVID area, and now we are developing all kinds of online collaborations, so our students can still get a little bit of international collaboration, because this year is not a year they can go abroad. But actually, this is for our side also very important, because having alumni like Dr. Devi at your side, we know we can send our medical students to our alumni so they can get some experience in Brawijaya, and then because they are at Brawijaya, identify themselves also when they go back to the Netherlands as Brawijaya alumnus or ambassador of Brawijaya towards Erasmus-MC. And that is what makes the medical student exchange very important, even though we are talking about research collaborations. And last but not least, 1 in 5 of our medical students chooses to become MD PhD. So they're not just going for their clinical training, they also go for a research training. The research education is in English, and that is also why we use this as a tool for our collaborations and how we can also generate alumni who become the drivers of our future collaborations. So on the one hand, we have research master programs. They take in general 2 years, or they just take 2 years. They have to write a research grant proposal at the end of the first year, because we think modern science is being able to write research grants. And in the second year, they must have one paper ready for submission to an international peer-reviewed journal. And though I do not go in detail in this, you have seen this morning Professor Bing. In the afternoon, you will see, or you will listen to Dr. Juliette Severin. Their programs as dermatologist or infectious disease specialist, microbiologist, there is a research master program called Infection and Immunity, and this is exactly fitting to their research programs. In addition to the research master programs, we also offer PhD programs. They take in general 4 years. The requirements or the guidelines are that you have 4 papers in the top 25% international journals in the field of your research. And as mentioned previously, there are about 250 PhD thesis defenses per year. But every PhD student gets at least 2 supervisors at Erasmus-MC. And also to stimulate our collaborations with your university, we can offer to share the supervision, and I think some, like Dr. Bing, are also doing that. We have joint or double degrees. For us, for our side, it's possible. And then, yeah, if it's possible from your side, we can work out a joint or a double degree. We can choose for a single MSc track, a combined master PhD track, or a PhD alone. And we have a very practical approach that's, yeah, we stick to both Universitas Brawijaya and Erasmus-MC's PhD criterions. I know maybe some of you would think it's intimidating to be able to have 4 papers in the top 25% international journals. But on the other hand, Dr. Devi did so. And I think it's very much feasible because this is actually an overview of the output of the last 10 Indonesian PhD graduations. So those 10 are of the last 2.5 years, I think. And in this left column, you see the number of publications they had at the time they went up for their exam. So it's also written here, 2 publications under review. Yeah, that is when they go for the exam. Nowadays, after the exam, they do have those publications, or submitted publications indeed accepted and published. So we look for the number of publications. We also send them abroad for courses, conferences, or sometimes research visits. And in this case, I did not include the conferences, courses, or research visits in Indonesia because I think 8 of those 10 were in collaboration with local supervisors. And yeah, we always think that honors and awards are very important for our PhD students. So we stimulate this a lot, like extracurricular activities, because we think it makes people more complete and makes it easier for them to successfully apply for the next step in their career. So they always have a scholarship, no matter it's LPDP, DICTY, or NWO. So both Dutch and Indonesian scholarships are possible. And then they look for travelships, poster awards, all that kind of things, or some extracurricular activities. So it is feasible, and I think the best part of it is if the PhD is in collaboration. You see here a lot of publications, and if it's done between 2 labs, one in Brawijaya and one in Rotterdam, then everybody shares. So it's always a winning way. Matur nuwun sangat. If you have any more questions, of course we have the discussion later on, but you can also send me an email and I will always reply to you. Thank you.
Matur nuwun, Dr. Raul, sami-sami. Thank you, Dr. Raultan, for your speech. It's a very interesting speech. And hopefully the students or our staff who will continue their studies will be interesting to doing research collaboration or doctoral programs at Erasmus and also for exchange program and maybe for vacation as well. Okay, for the next session, we will have our discussions for Dr. Theo's lecture. And due to limitation of time, maybe I will open the opportunity for 3 questions first. And I see that in the chat room, there are a lot of questions. So maybe I will read the question from chat room first for Dr. Ho Ping Theo. Are you ready, Doc?
No.
No? Okay. We have to be ready. Okay. I will read for the first question. It's from from Dr. Dewi Santosaningsih.
Yes.
Yes. The question is, yeah, what is the active compound of Staphylococcus epidermidis that keep our dry skin is healthy? Because in other side, Staphylococcus epidermidis is the one of the etiologic agent of acne. Why do the active compound of Staphylococcus epidermidis not protect us from acne? Please, Dr. Theo.
Okay. Thank you very much, Dr. Arvinda. And thank you very much, Dr. Devi, for asking me this question. Very difficult question to answer.
Sorry.
No, but this is a very interesting one. And also this, what the South Korean, the dermatology in Seoul has found, that acne patients younger than 20 has a lot of epidermidis. And if they are older than 20, the epidermidis is lower in acne. So there is an age difference of the role in epidermidis. But in general, if the Staphylococcus epidermidis has an impact, it has an impact via the lipotechoic acid, the LTA, and this LTA affects the toll-like receptor. And there is another substance of the 10-KD that's affecting the toll-like receptor 2 activation. So Staphylococcus epidermidis can warn the immune system by acting on this danger receptors, the toll-like receptors, and in that way it can mediate the production of antimicrobial peptide. So by stimulating inflammatory cells, the inflammatory cells will produce antimicrobial peptides, and the bad guys like Staphylococcus aureus will then be more less. That's probably the mechanism in this immune system skin microbiota. But in acne, besides this inflammation effects, it has something also to do with direct stimulation of the sebaceous, sebaceous gland cell. But this is one of the most prominent researcher in the sebaceous gland, Dr. Sibulis from Germany. I asked him this question, but he cannot answer very in detail what's happening with the sebaceous if you give Staphylococcus epidermidis to the sebaceous. So the most important one is epidermidis has an impact via LTA, toll-like receptor, inflammatory cells producing antimicrobial peptides. I hope that Dr. Devi is satisfied with this answer.
Yes, Prof. Thank you.
Okay, I satisfied, Dr. Dewi. Okay, thank you.
Doc.
Yeah, thank you, Dr. for the very brief explanation. And for the next question from Dr. Triyudani, the question is, I was wondering whether probiotics with single species, such as lactobacillus, can be used for skin therapy. Please, Dr. Theo.
Yes. So if using lactobacillus in small drinks and you can drink it or eat it, put it in your noodle soup, bamikua, then you can probably add something, a good bacterium. But if you add lactobacillus, it's usually good for your immune system. So if you have infectious diseases problems, infections, and also cancers, it's very good to use lactobacillus in your diet. But if you apply lactobacillus just directly into the skin, it does nothing. I tried to do it 1 week, but does nothing. As you can see, there's nothing happening on my skin.
Okay, I hope it's clear, Dr. Tiyudani, for the answer. And next question, Dr. Theo, is from Dr. Ansori. The question is, how is the role of microbiota in patient with immunodeficiency, either primary or acquired? For example, it's IV. Please, Dr. Theo.
Yes, yes. Thank you very much, Dr. Ansori, for asking me this wonderful question. Maybe Juliet has also an answer on this. But what we know, and certainly last year was a study from Mozambique comparing HIV and non-HIV, that at the beginning of an HIV infection, if you acquire HIV, you will shed a lot of, in your feces, a lot of adenoviruses. So in your feces, you find a lot of adenovirus. That's typical for HIV, what's happening. It is at the beginning, nothing is happening on the skin microbiota, and also not on oral cavity microbiota. So it's all in your gut. And you see a depletion of good bacteria, especially, and this is a very important one, Akkermansia municiphala. And Akkermansia municiphala is a good bacteria. You see that in HIV there is less of this Akkermansia. And I just also to know that after retroviral therapy, so you treat the HIV with antiretroviral therapy, you see that the changes in your gut microbiota are still there. So there is something as going back your immune system, but the changes in the gut microbiota are still present. I hope that's okay for you, Dr. Ansori.
Dr. Ansori, any other question or comments?
Thank you, Prof.
Okay, yeah, thank you, Dr. Theo, for the answer. We go to the next questions because there are a lot of questions for you. And it is from Dr. Bogi. The question is, inflammatory bowel disease also had several skin manifestations. Did unbalance of microbiota had a role for the appearance of skin manifestations? Please, Dr. Theo.
Thank you very much, Dr. Bogi. Yes, it has an impact, but it is more the impact of your changed immune system in general. So in inflammatory bowel disease, you see a lot of changes in the gut microbiota. It has an impact on your Th17, and in that way, it has also an impact on your skin's health. You have this immune-mediated Th17 diseases, and one of the most it has also an impact on your innate immune system, the neutrophils, macrophages. As you see in inflammatory bowel disease, you see skin diseases like pyoderma gangrenosum or the extra gastrointestinal manifestation of Crohn's disease. These are all due to immune system changes due to the microbiota changes occurring in IBDs.
Okay, thank you, Dr. Theo, for answering the questions. And before I continue to read the question from chat room, maybe there are audience who want to address the question directly to Dr. Theo, please. You can unmute your microphone.
No one there.
Okay.
I will ask the question.
Dr. Pinda.
Oh yeah, okay, Dr. Happy, please.
No. I don't want to ask question.
Oh, okay.
Ask question to Dr. Raul, but please read the question from the chat because it's so many, I think. And in here in Malang, it's very big rain, so maybe the sound is not good enough, I think. So Please, Dr. Herinda, read the chat first.
Yes, what's your question?
Okay, thank you, Dr. Happy. Maybe I will.
Okay.
Yeah. Do you want to ask questions? No?
I want to ask question to Dr. Raul actually.
Oh, yeah.
Because he is from the international collaboration, and I'm also completely new collaborator. But I think we finish the session from
Okay. Yeah.
question from Dr. Tio.
Okay. Okay. I will
Okay.
try to read the question from the chat room. There are one question directly message to me from Dr. Aryawan Adimulya. The question is, currently, especially in Indonesia, there is a trend of using probiotic Pro-EM1 to increase immunity against COVID-19. What is your opinion, Dr. Teo? Maybe you have experience or...
This is, thank you very much, a very good one. And what's the most terrible thing for COVID, and this is what I think is one of the smartest virus, it has to be with this protein, as you know, the spike protein. It has to enter the cell via the ACE2 receptor. And these ACE2 receptors are in the nose, in the oral, but also maybe in your lower tract of the colon and the rectum, or in your gastrointestinal tract. So there are so many doors to enter. And so if you want to use a probiotic to stimulate your immune system, then of course, then you will stimulate the Th17 or the Th1, especially in virus diseases. Th1 is the most important one. So if you have a probiotic, and I think at this moment to improve your immune system, that's like lactobacillus or other good ones like Akkermansia, you can promote your immune system, but you don't change the ACE2 receptor expression. And in that way, you still can get it, and maybe you can better eliminate and earlier and more quicker your COVID. But so you have to be careful, as you know, in the second part of the COVID, that's more a hyperinflammation, that there are too many cytokines. So if you are using probiotics, is at the end, if you are very sick, don't use it anymore. Otherwise, you have more cytokine production, then you will get more sicker. Don't use it at the end, but maybe at the beginning, it can help you a little bit.
Yeah, okay. Thank you, Dr. Teo, for your explanation. Okay, we go to the next question. It is from our dermatology and venerology residents. I think it's already answered, yeah, between topical and oral probiotic, which one have more benefit for acne? The answer should be oral probiotic, yeah, Dr. Teo. Okay, and next question, still from our dermatology and venerology residents, Dr. Vidya. The question is, what project that you recently do about skin microbiota and its relation with skin disease? And as both clinician and researcher, based on your side, what do you think is the most essential research that we need to pursue in the future? I think it's a very good question, Dr. Teo.
Thank you very much. Thank you very much. You are too creative there in Malang. The air is very good, so asking me very smart questions. So as I showed you, probably showed you, there are some things happening in the world, and this is why studies like industrial ecology and global sustainability, good for your climate and good for your Earth's health, that's probably the best therapy for everyone on this earth. Otherwise, if you are working only with microbiota, it depends where you live, whether you live in the desa or yeah, somewhere in the middle of the big city, whether you sleep very well, whether you smoke. This is are so many factors are happening uh, that I think it's better to attack the climate change, the pollution, and giving people a lot of green, healthy, natural surroundings. In that way, you will create a very, very healthy microbiota, not only on the skin, but also of your whole body, of the gut. But so that's probably my answer is try to eliminate the pollution and try to eliminate all the bad things that's happening in the world around you, also in Malang.
Okay, thank you, Dr. Teo, for the very clear answer. And very apologize due to limitation of time. I have to close this discussion session.
Yes,
Yeah.
thank you very much.
Yeah, maybe the audience, if you want to ask more to Dr. Teo, maybe you have a direct email to the Teo.
Yes,
Is that okay?
I show you on your send me by mail.
Okay, yeah. Thank you,
Yeah.
Dr. Teo.
Irwinda for Dr.
Yeah.
Raul.
Okay, please, Dr. Happy.
Hello, Dr. Raul.
Hello.
Hello, nice to meet you. So my name is Happy. I'm from the International Collaboration Unit in Faculty of Medicine. So one question that I want to ask, I think it is the important question because I'm wondering, I think we have already, not so many, but I think since Dr. Dewi Santoso Ningsi get PhD from there, I think there is a continuous collaboration between Brawijaya and Erasmus University.
That is right.
Yeah, so recently from Dr. Thank you from Prof. Teo. Because of me, we start again the collaboration in the education such like this and the previous in the, on March 2020. So I want to ask, so I know the from the document, MOU document, it is, I know it's not, maybe not so important for your university, but for us, because for the accreditation, something like that, I know for the essential collaboration, it's no need, but for the accreditation, something like that, we need the MOU. So what do you think? How many activity for the initial collaboration between us to start the MOU between Erasmus and Brawijaya University? Thank you, Dr. Rao.
Yes, when we go for MOU, we indeed start with, we need to have some collaborations going. And yeah, usually 2-3 is for me the reason to start preparing.
Really?
So you have two different departments. So it's not just for one department, but yeah, because then you can make it at departmental level. But if I have 2-3, I start discussing with with my executive board. And now you have dermatology and the medical microbiology. Yeah. And if we can add, and we have already added exchange students, because we see the education also as a separate part activity, because yes, medical students do not belong to a specific department. That means we have 3 activities. So you can send it to me and I start preparing the partnership. Yeah.
Thank you so much. We will make a note for all the activity that we already done, and also we will send the draft of our MOU to you so we can talk later. Thank you so much, Dr. Raul.
Yeah. Welcome.
Okay, thank you, Dr. Happy. Thank you, Dr. Raul, for the answer. And yeah, thank you very much also for Dr. Hoping Teo for a very interesting presentation. I'm sorry, there are a lot of questions actually, but the time is up, and we I hope we will meet again soon offline ya dok, not in a
Absolutely.
virtual meeting.
Terima kasih banyak ya, Dr. Herlinda.
Sama-sama
Thank you very much.
Dr. Tio.
Everyone have a nice weekend.
Thank you.
Okay, thank you dok.
Dr. Anshori, thank you very much. And please stay healthy, everyone.
Stay healthy.
Okay, stay healthy.
Thank you, Dok.
Bye-bye.
Take picture first. I
Well,
think we can take
for the
picture.
next, yeah,
Take
we have a photo session first, Dr. Tio.
For you,
Okay.
Dr. Raul, also please can you on the video?
Yes.
Okay. Please,
Yeah, we will
Dr.
take picture.
Yeah, please, Dr. Nurrahma, you arrange the photo session.
Thank you, Dr. Herlinda, Dr. Raul, and Dr. Theo. Ladies and gentlemen, we will have a moment break session. We would like to invite all of the speakers and audience to turn on the camera to take a picture together. We will have maybe several takes for the picture. I see there are 80 participants, so maybe we will have 4 or 5 takes for the screenshot. And for the photo session, we will be led by IT team. For Dr. Luki, the time is yours.
Good afternoon, ladies and gentlemen. I'm Dr. Luki Pratama from IT team. For all speakers and audience, please stand by in front of your camera and make sure your camera is on. We will take the picture in several sessions. 4 sessions actually. The first session we will start in 3, 2, 1, and the second session in 3, 2, 1. Okay, the third session in 3, 2, 1, and the last session in 3, 2, 1. Okay, that's it. Thank you, Professor Bing.
Thank you very much.
Thank you very much.
Thank you very much. Okay.
Terima kasih.
Okay, let's start for the presentation because we'll have interesting lecture. Okay, for the next guest speaker will be Dr. Juliet Severin, PhD. Welcome, Dr. Juliet Severin. And Dr. Juliet Severin will be presenting about the emergence of antibiotic resistance in human intestine flora caused by overuse of antibiotics. Before we start the presentation, allow me to read the curriculum vitae of Dr. Juliet Severin's PhD. Since 2006, Dr. Juliet Severin has been working as a clinical microbiologist with responsibilities in infection control, supervising the diagnostic microbiology lab, and visiting the wards as a consultant. She has the medical coordination of the unit infection prevention at Erasmus Medical Center. And in 2009, she obtained her PhD degree. With her research focused on antimicrobial resistance and infection prevention and control. She is doing this in the Netherlands, but also in some Asian countries such as Indonesia, Vietnam, and India. And from 2010 till 2017, she was a member and later chairman of the control board of the Working Party on Infection Prevention, or WIP, coordinating the development of national guidelines on infection prevention in Dutch healthcare. And since 2016, she is the vice chairman of the National Signaling Consultation of Hospital-Acquired Infection and Antimicrobial Resistance. Okay, please, Dr. Juliet Severin, PhD, you have 45 minutes. Now time is yours.
very much for this very kind introduction. Can you all hear me well? And can you also see my screen?
Yes,
Yeah.
loud and clear.
Can you still see my screen now?
Yes.
Good. So thank you very much. It is an honor to be invited in this session. Thank you very much for organizing this, especially Dr. Davy. And it's good to see you again.
Good to see you too.
Digital, but it's okay. Actually, sorry that I had to miss the presentation by Prof. Theo, but unfortunately, as you know, we are in the second wave of COVID here in the Netherlands, and it's a bit hectic. But it is kind of a relief now to talk about another very big problem, and I think the problem of antimicrobial resistance is going to hunt us for a couple of decades. And I think COVID will pass away in hopefully 2 years or so, but the problem of AMR will stay with us. And we need to take care of this constantly. So, but the presentation of Professor Theo was very interesting. I do not think we have any overlap, but maybe I'm going to say some things that are different than what Professor Theo is saying. So that can be a nice discussion then in the end. So this is the title of my talk that was given to me. So the emergence of antimicrobial resistance in the human intestinal flora caused by use and overuse of antibiotics, because of course we have to avoid overuse of antibiotics, but antibiotics are also very important in our the daily routine of medicine, and it makes our lives much better than it was before the antibiotics were there.
Excuse me, Dr. Juliet, maybe you can change your view to slideshow view, not in speaker view. Yeah. Speaker, the last one. Yeah, okay.
This like this?
Yes.
Good. Yeah. So my disclosures are, I'm in a collaborative project with Milieu, and I received some funding from Zon MW and the Dutch Ministry of Health, Welfare and Sports. But of course, my other disclosure is that that I really enjoy going to Malang. Of course, in the collaboration that we had with Dr. Davy and Professor Santoso, we visited Malang quite some times, and it's always very good to be there. It's a very nice city, and you are receiving us always in a very kind way. So thank you for that. It's a pity that we cannot go there now. So what I'm going to talk about, first the problem. I will give you a little bit of background, and then talk you through the 4 effects that antibiotics can have on the gut and the emergence of AMR, and then the approaches to deal with these effects. And I will end up with a summary. So the problem was nicely reviewed a couple of years ago by O'Neill and co-authors, people from the UK. And they estimated that by the year 2050, the deaths that are attributable to antimicrobial resistance is very high, as you can see, millions. We're talking about millions of deaths, and the burden of AMR is especially in Asia and in Africa, with more than 4 million deaths estimated on a yearly base. So this is what is in our future, and so the time for action is now. When we look at studies, what the risk factors are of antimicrobial resistance, then almost all studies will show that use of antimicrobials and so antimicrobial agents is the main risk factor for the emergence of resistant microorganisms. So, of course, I wanted to start with a study that was performed also in Malang, but also in Denpasar there was a third Semarang it was, yeah. So this study was performed by Devi and published in 2014, and she looked at the epidemiology of Staphylococcus aureus that were MRSA in hospitals, so in Java and in Bali. So, and there were more than 1,500 patients screened at discharge, and of these 1,502 patients, 4.3% of them had an MRSA, so was a carrier of MRSA. And she looked at the risk factors for this, and there were a couple of risk factors, but again, a very important risk factor was antibiotic therapy during hospitalization, and that was an independent determinant for the carriage of MRSA with an odds ratio of 2.6. So other studies in Indonesia are showing this as well. And I wanted to show you some data from Jakarta, from the intensive care unit in the Cipto Mangunkusumo Hospital in Jakarta. And this is a study that is still being performed by Dr. Lilia Rosa Saharman. She's a PhD student and she will defend her thesis in next month, so November 27th. And she screened patients that were admitted to the ICU in her hospital. And in total, this was 412 patients, and they were screened on admission and at discharge, and then weekly during intensive care unit stay, rectum and throat. And what she saw is that 26% of the patients acquired a carbapenem non-susceptible Acinetobacter baumannii. 9% acquired a carbapenem non-susceptible Klebsiella pneumoniae, and 8% a carbapenem non-susceptible Pseudomonas aeruginosa. And it is exactly these three microorganisms that are such a threat to hospitals all around the world. And I think these are also the top 3 microorganisms that are a problem in Indonesian hospitals. So the Acinetobacter, the Klebsiella, and the Pseudomonas, and then especially the bacteria that are resistant to the carbapenems. Because when these microorganisms cause an infection in patients, then it's almost untreatable. So this is what the patients acquired during ICU stay, and some of them, so even 4 patients, acquired all species. So this is a problem, of course, for the patients. And again, looking at risk factors for all the 3 microorganisms, we saw that previous use of antibiotic was a risk factor. So for the Acinetobacter baumannii, it was carbapenem therapy. For the Pseudomonas aeruginosa, it was also the carbapenem therapy. And again, for the Klebsiella pneumoniae, it was the previous treatment with the carbapenem. So treatment with antibiotics will select for or increase the chance that patients carry these kind of microorganisms. So then we go a little bit to the background, and then later I will come back to this study again. We're talking about the human intestinal flora, and the word microbiome was already mentioned a couple of times, and I think also in the presentation by Professor Theo. The word was actually first used for the first time by a plant microbiologist, John Whipps, in 1988. But it was David Relman that really asked attention for this concept. And this was in a very nice article in the Journal of Infectious Disease in 2002, where he stated that the development and clinical application of molecular methods have led to the discovery of novel members of the endogenous normal flora, as well as putative disease agents. Current challenges include the establishment of criteria for disease causation and further characterization of the human microbiome during states of health. So he introduced this concept, and of course, after this publication, there were many studies about these correlations between the microbiome and a lot of diseases. So the words microbiome and microbiota is often used, but there is a difference between these two words. And this is also something that I would like to mention before I continue. So the microbiome is this whole concept of all the microorganisms together and all the activities that these microorganisms show in relationship to the environmental conditions. So then this whole concept, that is the microbiome. And when we're only talking about the microorganisms, then we're talking about the microbiota. And actually, I will mainly talk about this, the microbiota, and not so much about the whole theater of activity. That's actually very complex, and I think Professor Theo has talked about that a lot already. Talking about the intestinal flora, we have to keep in mind that there are many factors that have an effect on this gut microbiome. And now I'm only going to talk about antibiotics, so only this small piece, and we have to keep in mind that there are many other factors that can have an effect. So this is the makeup of the normal gut flora, and the main phyla that are in the normal gut flora are the Firmicutes, the Proteobacteria, the Bacteroidetes, and the Actinobacteria. So as you may have heard from Professor Theo, there are more than 10 to the 14 bacteria in our guts, and about 1,000 are known and can be cultured, and there are probably many more that cannot be cultured or not cultured yet. These are very important. The anaerobic bacteria are especially important, and I will come to that later because they protect our gut from the bad bacteria and also from the resistant bacteria. So the anaerobic bacteria are very important for a normal, healthy gut flora. So the 4 effects that antimicrobials can have on the gut flora are the alteration in the population structure, enrichment for resistance, increased mobilization of genetic elements, and the availability for niche intrusion. And I will go through these 4 effects. So I will start with alteration in the population structure. So this is a very complex topic because there are many alterations in this gut flora, and there are many antibiotics, and each antibiotic can have a certain effect. So I was lucky that there is a very nice review. It was published just 1 year ago, going over all the publications on this topic. So what you see, first of all, she looked, Petra Zimmerman, she looked at all the the publications with any effect on the gut flora. And the one thing that she immediately described was that there are different techniques, and of course different techniques will give you different results, and they will give you a different picture of what is actually going on. And I also saw that this was one of the questions that was raised in the chat box. What are the methods to analyze the intestinal flora, so the microbiota? So it can be done by metagenomics, so a genomic-based analysis, and it can be done by culturomics. There are also other approaches like looking at proteins only, for example. But really, if you want to look at the population and what the population diversity is, then these are the two main approaches. And when you use a genomic approach, of course, you will find basically everything, because you will, it is a PCR-based method, and everything that can be multiplied is something you will detect. So the strength is that you will get a lot of data. You will also get data on the uncultured bacteria, or bacteria that cannot be cultured. And you will get a very nice overview of all the different phyla that are present. But it also has some weaknesses. And apart from that, it is kind of complicated to do. And you really need to think about the basics, so the extraction, but not only the extraction, also the collection of the samples, how you are storing and transporting the samples. And then, so the extraction, and then the primer. So if you are not choosing the right primer, then you may miss some microorganisms. And then it's very much dependent on which bioinformatic pipeline you will use, what kind of results you will get. Of course, you will not only get live bacteria, but also results from transient DNA or dead bacteria. And the populations that are present, but only in a very low level, so minority populations, that are the populations that you will miss. These will be insufficiently detected. So when you go to the culture-based methods of analyzing the gut flora, so that's called culturomics, you can imagine that that is a lot of work, because there are so many bacteria, and you need a lot of different plates with a lot of selective agents. So you have to use antibiotics, filtration techniques, thermic shocks, etc., etc. So this is a technique that is very well performed in some labs in France. And the good thing about this is if you find the bacteria, then you can also look at the resistant mechanisms that are inside those bacteria. So if you only do the genomics approach, then you can look at resistance genes, but then you can never know if that resistant gene belongs to that bacterium. So it is an independent analysis. In the culturomics approach, you can have bacteria, live bacteria, and then do the susceptibility testing and check for resistance genes in that specific bacteria. And you can really go into the species identification, which is not really possible in the metagenomic approach. So in the metagenomic approach, you can say there's Pseudomonas, but you cannot really say if it's a Pseudomonas aeruginosa, for example, and this is possible in the culturomics approach. But the culturomics approach, of course, takes weeks and weeks, and it's a lot of work. And for the analysis of only one sample, yeah, that's a really lot of work. So these are the two techniques, and it also shows what are the strengths and the weaknesses of each technique. The good thing in the culturomics approach that I did not mention yet is that you will really detect minority populations if you use good selective plates and culture methods. So, but going back to the overall effects of antibiotics to the gut flora, this is a summary of all those articles that that she looked into for this review, and she made an overview per antibiotic. She wrote down if it's detectable in stool, yes or no. If it is selective for Clostridium difficile, which of course is a microorganism causing a Clostridium difficile associated diarrhea. If there's an increase in resistance, and the longest reported perturbation. So penicillin is a very good antibiotic if you look at the effect it has on the population structure of the intestinal gut flora. Minimal change in bacterial abundance, no change in fungal abundance, and no increase in resistance. So from a microbiome point of view, penicillin is a very good antibiotic, but of course it's a very narrow spectrum and it's not possible to use it for all infections. Then looking at amoxicillin, so the longest reported perturbation is about 12 months. So this is this has a long term effect. And as we know that there are quite some Enterobacterales or Enterobacteriaceae that are intrinsically resistant to amoxicillin or ampicillin. So for example, the Klebsiella species and the Enterobacter species. So this is what you will select for. So these will be increased when you use this antibiotic. And the decrease, of course, is in the species that are susceptible usually to amoxicillin. So the normal E. coli and quite some anaerobic species. Then I will go to the next slide because this is the cephalosporins and the carbapenem antibiotics. And when you look at the cephalosporins, and I know that in Indonesia it's mainly the third generation cephalosporins that are used, so I will focus on this group here. And then you see that Enterococcus species will mainly increase, but you see a lot of species that are decreased, and especially the anaerobic bacteria are decreased when using third generation cephalosporins. And the same accounts for the carbapenems. So the carbapenems also have a very strong effect on all kinds of anaerobic flora. But when it comes to an effect on these anaerobic bacteria, I think the cephalosporins or the quinolones are the absolute winners. It is amazing because quinolones by itself, so ciprofloxacin, does not have an effect on anaerobic bacteria. But when you look at the effect it has on the microbiota in the gut, then it has it has a tremendous effect on this anaerobic bacteria. There is a decrease of almost a complete anaerobic microbiota in the gut. So that is why, for example, ciprofloxacin is maybe not such a good antibiotic from the point of view of microbiome. So overall, penicillin had the minor effects on the intestinal microbiota. A decreased bacterial diversity was seen for quite some antibiotics. But here is again the ciprofloxacin as I showed, and of course the amoxicillin clavulanic acid. Changes in the intestinal microbiota were observed within 24 hours after the start, and they persisted after treatment was especially long for ciprofloxacin, clindamycin, and the combination of clarithromycin and metronidazole. So these are the changes in the population structure. And as you can imagine, for example, what I said, the amoxicillin will definitely decrease the normal wild type E. coli and will select for Klebsiella and Enterobacter that are intrinsically resistant to amoxicillin. So this is enrichment for resistance. This alteration in population structure will also have an effect on this, but I will talk about that later. First, I will talk about this enrichment for resistance. So bacteria that are already present in the gut flora, but in very low levels or even undetectable levels. So the example that I just gave about amoxicillin selecting for Klebsiella, that is a normal process. Most people have Klebsiella in their gut flora, so that will be selected. However, it's also possible that people already have a highly resistant microorganism in their gut, maybe in very low levels, and that will also be selected when you give certain antibiotics. And this was nicely illustrated in a paper from 2008, a couple of years ago, and it was actually in pigs, but it shows exactly the point of this mechanism. So these were pigs and they came from an isolation unit, so they were supposed to be free of resistant microorganisms. They were inoculated with the CTXM1 positive E. coli. So this is an ESBL that was also resistant to a quinolone. So they were inoculated orally. Then they received antibiotics for 3 days. That was injected in their muscle, and that was amoxicillin, and then two cephalosporins. This one is a third generation cephalosporin used in veterinary medicine, and the other one is the fourth generation cephalosporin. And then they analyzed the cultures of the feces by culture. But then when they already started the experiment, they discovered that 90 of the 20 pigs were already carriers of an ESBL before starting the experiment. However, these E. coli were of a different type. So they could select, and so they could see the difference between the ESBLs that were already present and the ESBLs that were inoculated. And what they saw was the strain that was inoculated disappeared quite fast and was not detectable anymore, except for the cefquinone group, which is here in picture C. This is the controls. This is normal E. coli, but here this is the ESBL E. coli that was already present in the gut of the pigs, and then you see that it was still in low levels present in the control group, but for the pigs that received the third and the fourth generation cephalosporins, there was really a selection, and these were the strains that became abundant. So when this becomes abundant, of course, if the pigs will spread it more, and there's also a chance that they will get sick of it. And if we would translate this to humans, this is probably also what we see when people are treated with ceftriaxone. This is what you select. And when these kind of ESBLs are selected for, then people will transmit more ESBL positive E. coli to other people, to the environment, and there's also a bigger chance that they will get sick from it. Then we go to the third effect of antibiotics on the gut flora, and this is an increased mobilization of genetic elements. So then we're talking about conjugation, transduction, transformation, and plasmids. There's some debate about how often this occurs, but what we know is that when bacteria get stressed, and bacteria can become stressed if antibiotics are in their environment, then they will have an SOS response, and this SOS response will increase the production of plasmids and the release of plasmids. So, but what it really has as an effect in emergence of resistance, that's still under debate. We had a very nice example in our clinic here in Erasmus-MC that was published a couple of years ago. So I would like to show this. This is about VRE. This was a patient who was admitted, it was a female patient, about 65 years old, and was admitted with a cholangitis, and of course treated with antibiotics, and she was operated and then got a post-operative infection. And in this course, at some point she had, and this is in 2012, she had a positive blood culture with an Enterococcus faecium, but sensitive to vancomycin and resistant to amoxicillin. This was in a blood culture, and we suspected her of having a catheter-related infection. So she, the treatment with vancomycin was started, and because she had some other problems with abscesses in her abdomen, she was later on continued on vancomycin. She received vancomycin for a very, very long time. These are the levels of vancomycin in her blood. And then in January, so that is about 1 month later, there was another patient in the ward who was positive for a VRA. So we did a contact investigation, and we checked this lady for carriage of a VRE, and we found a VRE. But so a vancomycin resistant Enterococcus faecium in her rectum. But this was not the one that we were looking for in the contact investigation. This was a Enterococcus faecium with the VAN-D antibiotic resistance gene, which is very unusual, and we had not seen that before in Erasmus-MC. So we started to analyze these two enterococci together with colleagues in Utrecht, and we looked at the genomic island where this VAN-D resistance gene was located, and we found out that it actually matched the VAN-D resistance gene that is present in some anaerobics in gut commensals. So these are the two bacteria, the anaerobic bacteria that are part of our normal gut flora with very difficult names, and these have a VAN-D resistance gene. So it is our hypothesis that this previously, so this one that was previously sensitive to vancomycin, during the course of the vancomycin treatment, that there was a transfer of this VAN-D gene of the anaerobic gut flora to this Enterococcus, and then a new VRE appeared in her gut flora. But this is probably a very rare event. It was a very nice example of what can happen in the gut flora, but we think it's very rare because we have never seen after that such an event with a VAN-D, for example. What is probably much more common is not this transfer of genes, and then there are plasmids or genomic islands, but probably it is mutations in the chromosome itself. And I want to show you an example of ciprofloxacin resistance in E. coli. These are the 4 mechanisms of ciprofloxacin resistance in E. coli. It can be a target alteration, a decreased ciprofloxacin accumulation, so an efflux pump. It can be a physical blocking of the ciprofloxacin target or an enzymatic modification of ciprofloxacin. But in E. coli, this is the most important resistant mechanism. So this is the modification of the target. And that happens in the what is called the QRDR, the quinolone resistant determining region. And it's just basically one amino acid mutation that can already raise the MIC a little bit. And what's very interesting is when you have one mutation already in an E. coli, then it is much easier for the E. coli to have a second mutation and also to get additional resistant mutations, so to become more and more resistant. So this is shown here. This is actually from also from Indonesian E. coli isolates with a very high MIC to ciprofloxacin and a very high MIC to nalidixic acid, which is also a quinolone. And when you see, when these MICs are very high, so these are very resistant, then you see that there are a lot of mutations in this this target target piece of the genome, so the QRDR, and this will of course leave the E. coli resistant. And the funny thing about this is that we found out that these were E. coli, and later on we checked if these people were treated with ciprofloxacin before these we found these E. coli, and all patients that had these E. coli, so very resistant E. coli, were all treated with ciprofloxacin just before we found this E. coli. But when we look at some other E. coli, here for example, so this has a ciprofloxacin MIC of 0.25, which is still, you could think, well, we can treat an infection if this is the MIC, but then the MIC of the nalidixic acid is already 64. There is already a mutation, so then we know if this E. coli is causing a urinary tract infection and you will treat the patient with ciprofloxacin, then the chance that other mutations will arise is very high. So this is how we deal with it in the clinic in Erasmus-MC. So sorry, this is a bit in Dutch. This is how we report our E. coli susceptibility patterns. So if the ciprofloxacin has a very low MIC, but the norfloxacin, which is also an early generation of quinolone, is resistant with an MIC of 1, then we give, we report to the clinic, please take care, please take care. This E. coli is not sensitive to norfloxacin, so resistance to ciprofloxacin will increase much faster when you will start treatment with ciprofloxacin. So this is how we deal with it in daily clinic. And this is something that is still, yeah, I think there's still room to investigate this deeper, because maybe a normal cystitis can still be treated with ciprofloxacin in this case, but for a sepsis, it is more complicated. So I will go to the last effect, and that is the availability for niche intrusion. And that, of course, has to do with the population. And this has to do with colonization resistance. And I think this is a term that you have heard before. It's a mechanism whereby the intestinal microbiota protects itself against incursion by new and often harmful microorganisms. And this was first identified a long time ago in '67. And that was when animals were treated with streptomycin, and they were much more susceptible to Salmonella enterica than animals that were not treated with this antibiotic before. This is very well studied for all kinds of enteropathogens. So for E. coli, Yersinia, Shigella, Salmonella. This is very well studied. For antimicrobial resistant microorganisms, not so much, but I think the concept applies very well to AMR as well. You can imagine if the commensal E. coli are all killed by an antibiotic, then there is room for other microorganisms to take that place. There's of course also things with nutritions, etc. But I think this is probably, when talking about antimicrobial resistant microorganisms, then they can adhere to the gut.
I'm sorry, Dr. Juliet. You have 3 minutes more.
3 minutes more. Yes. So then I will just quickly say something about what I think was happening in the intensive care units in Jakarta. When we're talking, for example, about the Pseudomonas aeruginosa, these were patients that were treated with carbapenems before, so that kills almost all anaerobics and a lot of normal flora. So there is a lot of room for resistant microorganisms to adhere to the gut flora, to the gut. So that makes sense. It also makes sense that if patients were maybe already colonized, but low-level colonization before they were admitted to the intensive care unit, and when this antibiotic was started, then it was selected. You can also imagine that there are, because for carbapenems, it can be a carbapenemase gene, but it can also be mutations in the chromosome that enhance efflux pumps, for example. OPRD is known to cause carbapenem resistance. And actually, we think that it's all these mechanisms that probably played a role in this, what we saw in the intensive care unit in Jakarta. So I'm talking much more about these effects. And I also had some solutions, or not solutions, it was approaches to deal with these effects. And I will skip that for now then. I just want to mention that when we're talking about prevention of these things to happen, is of course antimicrobial stewardship, which is a coherent set of actions which promote using the antimicrobials responsibly. But it's also good to have these concepts in mind when we think about antimicrobial stewardship and the effect that the antibiotics that we choose have on the gut microbiome. So the first sentence is, of course, always a key element of any antimicrobial stewardship program. So the narrowest antibiotic is best and the shortest time is best. But maybe we should also think about other things, about that we should select more IV agents that limit the biliary or fecal excretion. For example, cotrimoxazole is not entering the gut flora a lot, so that is good. But ceftriaxone and cefotaxime are excreted in the feces, so is not a good option maybe. And then maybe we should select oral antibiotics that only have limited effects on the anaerobic bacteria. And we have to think about how to do this IV to oral switch, which is of course good because then the patient does not need an IV entry and there's less catheter-related infections, and it's also less work for the nurses to prepare the antibiotics. But these are the things that maybe we have to keep in mind as well. Talking about the more holistic concept, antimicrobial stewardship is not only about people, but it's about the whole environment as well, and about animals, and about what is in the water and what is in our environment. And I just wanted to have this picture in my presentation to join the holistic view of Professor Thiel, because I think when we're talking about the problem of antimicrobial resistance, it's really this concept of One Health. This holistic view is also very important. So to summarize the effects of antibiotics on the human intestinal flora, so they cause less diversity, the population really changes. It is causing a selection of bacteria that are already resistant. Transfer of mobile genetic elements and resistance genes will be enhanced, and there is loss of colonization resistance. There are several approaches. I did not talk about a lot about the last two that I just have here on my slide, but antibiotic stewardship is of course a cornerstone to combat antimicrobial resistance. So thank you very much, and I want to end with a quote from an unknown infectious disease specialist. Antibiotics are the only medications that affect not only yourself, but also other people. So thank you for your attention.
Okay, thank you, Dr. Judith Zefrin, PhD, for the very interesting explanation, and also for the very interesting quote about the antibiotic resistance. And next, we will have our discussion session for the next 15 minutes. And I will read the questions from chat room for Dr. Juliet. Okay, for the first question, Doctor, it is from Dr. Rahma. The question is it necessary to give supplementary good bacteria for patients who receive antibiotics to keep the gut environment healthy? And does it help to prevent antibiotic resistance? Please, Dr. Juliet, you can answer.
Yeah, so I did not talk about the approaches to deal with this problem, but of course, probiotics are mentioned a lot, but I think there's not enough scientific evidence yet to really use it in daily clinic. And from a microbiology point of view, there is some concerns about the bacteria that are used as probiotic, because it is also possible that you will introduce new resistant mechanisms, or we are not really sure about what we are doing when we are introducing new bacteria in the gut. And I think that is still an area that needs to be exploited more, I think. There's a balance between, of course, it can have a good effect. This is because the anaerobes are so important, but we have to think about the side effects and the other effects that it can have.
Okay, thank you, Doctor, for your answer. And we go to next question from Dr. Devi. Probably you have known her very much, Dr. Devi Santosaningsih. The question is, how long the gut flora will become resistant after an antibiotic exposure?
Well, the effects can be very prolonged. So I showed you the effect of clarithromycin and metronidazole. The effect is 4 years. And I think the effect is much longer than we think. And in most studies, the follow-up time, of course, is limited. But the effects will be probably longer than we think. And once a resistant microorganism has been selected or was introduced because there was a niche for it, of course, it is very difficult then for your own gut flora to get rid of the resistant microorganism. So it depends on how resilient your microbiota is, how fast the resistant bacteria will be lost. And what we see, or what we know, when talking about this resilience of your microbiota, is that all these factors in this picture that I showed and Professor Thier showed, these are important, like dietary factors, but also age is very important when we're talking about gut resilience. What we know is that, for example, younger people, when they receive an antibiotic, the effect will be much shorter than for older people. For older people, their gut flora is not so resilient. So there's also an age factor there. Yeah.
Okay, Dr.
Thank
Dewi.
you, Julia. Terima kasih.
Okay. Thank you, Dr.
Sama-sama.
Juliet. Yeah. And for the next question from Dr. Shot Zulkarnain, the question is, would you mind to explain us more detail regarding the option of antibiotic which can be used to manage the infection caused by extended spectrum beta-lactamase or ESBL producing E. coli? Is the target affected the drug of choice? Shall we depend on VTech result? Please,
Thank you for this question. I think we can talk hours and hours about this problem. The choice of an antibiotic for an infection caused by an ESBL producing E. coli, yeah, it depends definitely on the organ that is affected, if it's a urinary tract infection or it's an abscess. What we know is that because some antibiotics are not good for treatment of an abscess. If you have a very large abscess, then cotrimoxazole will not be a good antibiotic. So there are many factors that influence the choice for an infection with an ESBL. And unfortunately, carbapenems are still the best choice probably if there is a very severe infection. And of course, this is something that you want to limit. I think that is exactly the reason why it is so important to try to reduce ESBLs. Because when there is a lot of ESBLs, then you have to use carbapenems in case of a severe infection, and the carbapenems have a terrible effect on the gut flora and also will select for even carbapenem resistant microorganisms. So if we start at preventing ESBLs to emerge and to spread, then I think we can try to stop this chain better than than only focusing on the carbapenem resistant strains.
Okay, thank you, Dr.
Thank you very much.
Yeah, I think it's clear, Dr. Shot. Okay,
yes.
We go to the next question from Dr. Ansori. The question is there any suggestion for people with immunocompromised state that often get infection so that the need to treat it repeatedly with antibiotic?
Yeah, that's also a difficult question. There is a lot of different ways of being immunocompromised. And when you're immunocompromised because of a leukemia, for example, then you really depend on good antibiotics to survive, actually, because you don't have any other immune cells from yourself, especially when you're completely neutropenic. So it depends on what kind of immunocompromised state a patient has, but these are the patients that survive by having antibiotics. And of course, we need to protect them for getting infections. So I think for those patients, it's more important to try to prevent infections. Then we can do something about withholding antibiotics or giving not giving beta-lactam antibiotics, for example, because the beta-lactam antibiotics, of course, are bactericidal, and this is what those patients need. I don't know if this answers your question a little bit, Dr. Anshori.
No, thank you. Thank you, Doctor.
Okay.
Is it clear, Dr. Ansari? Okay. Yeah, thank you, Dr. Juliet. We still have more questions, about 3 more questions. Next question is from Dr. Chitra. She is a resident of microbiology department. The question is whether after antimicrobial therapy is always accompanied by mutation and resistance, Dr. Juliet?
Yeah, thank you for this question. I think when it comes to the quinolones, the answer will be yes. But when it comes to other antibiotics, this is probably this does not always occur. But exactly in what the percentage is, I think that's never been studied before. So there's room for some more studies, I think.
Yes.
Yeah.
Okay, thank you, Dr. Juliet. Next, from Dr. Devita. She is a resident from Dermato and Venerology Department. The question is whether prolonged use of antibiotic therapy more beneficial for preventing resistance. Is there a current solution in patients who need use antibiotic for a long time?
Is this question for dermatology patients that need antibiotics for a long time? Is this
maybe not for only dermatologic patient, for all patient, I think.
Because we try to avoid prolonged use of antibiotic therapy, and there's still studies being conducted about what is still a short time of antibiotic use, but still safe and effective. And for some important infections, we already know that we do not have to treat for a very long time. For example, community-acquired pneumonia can be treated for a much shorter time than we did 20 years ago, for example. So what is safe is important, but the shorter, the better. That is the paradigm, actually. But of course, if it is too short, then the infection can re-emerge and reoccur, and then it's and then it can be even resistant. So that's also a balance about good treatment, but not too long. Yeah.
Okay, thank you very much, Dr. Juliet, for your explanation. And I think it was the last question for this meeting before, because we have to limitation of time. I'm so sorry. I also thank you very much for Dr. Juliet Zafrin, PhD, for your very interesting presentation and very important presentation about antibiotic resistance, because we as a clinician have to know this and to prevent this further. And next, I have to close this discussion session. And I think we have already reached the end of these guest lectures this afternoon. And before ending these guest lectures, as a session as a moderator, I will read some resumes for our two expert lectures. The first is about, Dr. Teo is about skin microbiota. The important message is we have to maintaining gut and skin microbiota homeostasis. It is very important to prevent and treat any skin disease. And there are many factors affecting the dysbiosis of microbiota, such as geographical location, diet, maternal lifestyle, medication, and some environment pollutants. And we should always be taken into our mind as a clinician. And the second message for the Dr. Juliet Zafrin lecture, that we have to always take to our mind the excessively widespread use of antibiotic has created many threats. We have to try our best to understand the microbiota nature and choosing the best antibiotic which match with the pathogen. We should always be our first measure as a clinician. I think that's all my resume for these guest lectures. And I would say thank you very much for Dr. Hoping Teo and also Dr. Juliet Zafrin for a very interesting lectures this day. And next, I will return the program to Dr. Nurahma Fitri. Thank you very much.
Thank you, Dr. Herwinda. So, ladies and gentlemen, these are the lectures from Dr. Hoping Teo and also Dr. Juliet Zafrin. Thank you, Doctor, for your very interesting and insightful lectures. I'm sure all the audience will get the value and benefits from them. And we also thank you for Dr. Raul Tanhadinegoro for the explanation regarding the research and collaboration in Erasmus Medical Center. And we also thank you to Dr. Herwinda Bramanti for guiding us through this event. Ladies and gentlemen, for our next agenda is closing ceremony. Allow me to invite Dr. Happy Kurnia Permatasari, PhD, as the head of International Collaboration Unit, Faculty of Medicine, Universitas Brawijaya, to give a closing speech. Please, Dr. Happy, the time is yours.
Thank you, Dr. Fitri. So, Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you one more time to Prof. Teo, Dr. Raul, and also Dr. Juliet for a great and very beautiful presentation and lecture for us. And I hope this collaboration will continue for the next step and more activity between Erasmus and Brawijaya Faculty. Dan untuk Bapak Ibu semua, saya ucapkan terima kasih sudah dapat bergabung dan mensupport acara ini. Dan juga dari saya, especially for Dermato and Venerology Department and also Microbiological Clinic as a organizing committee for this event. Dan saya juga terima kasih untuk departemen-departemen lain yang bergabung di acara ini. Saya harap ke depannya dari departemen lain juga bisa menginisiasi kolaborasi dan melakukan kegiatan-kegiatan kolaborasi antara Erasmus dan Brawijaya University. Kalau misalkan membutuhkan bantuan dari kami di International Collaboration Unit, kami sangat terbuka sekali. So, okay for today. Thank you so much. And I would like to close this webinar. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Give applause.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you.
Thank you, Juliet.
Terima kasih semuanya. Thank you, Dr. Juliet, Dr.
I hope to meet